if you look at the different civilizations across the world, you'd see that all of them, the Chinese civilizations, in India too by the Ganga River, and in Odisha by the Mahanadi River, civilizations have progressed along the rivers, which are the freshwater sources. But what we find very unique as compared to other parts of the world is that in Bharat, India, we have an ability, we have a capacity to bring water to where our habitation is. That is the beautiful contrast. In other parts of the world, people went and settled to where water flow was. In Bharat, we settled, and also we had the skill, the capacity to bring it to where we were. How come? How is this possible? It's a very important question in the idea of governance of water. In sustainable governance of water, it's an important point. We'll see that now. For the next few minutes, we'll see that. See, when you look at water itself, the idea of harnessing waters, if you look at the river flows in India over the millennia, not a century, millennia, if you see, India has one of the very high, almost the second high river flow in the world. Of course, Brazil has the highest flow because of the Amazon River. And if you compare between India and the USA, USA is 3 times the landmass size of India, but India has proportionately more river flow. If you see, China is almost 2 times the size of India, Europe too, but India in proportion has got a lot more of river flow. That's the beauty is what we are seeing here. And the irrigated lands, if you see, 1/6 of the irrigated lands as recently as 40-50 years ago was in India. That means what's been built up over 5,000 years of irrigation, that the irrigated lands of the world.
So here actually many of us, especially in the current generation, we may gloss over the word irrigated. What exactly do we mean? It's such a common term, but to understand the profoundness of the word irrigated, it means that we are arranging for water to come to that land. It is not just the natural rain alone.
Bringing it.
We are bringing that water to that land. That is when it is irrigated.
Through a planned human effort across years, across decades, across centuries, across millennia, and mind you, across generations, across climate terms, we're bringing it. That's the beauty of what we have done in this land of Bharat. Look at the annual rainfall too, because that's important. That's what leads to all the irrigation. As we said, USA is 3 times the landmass size of India, but India and US gets very similar amount of rainfall. Look at that. That means what? We get so much more rainfall. So when somebody tells us rainfall is reduced or increased, we are getting sufficient rainfall for this land. The point is, how do we use it? That is the key point that we have to see. Where in the world do we get the highest rainfall? All of us are now well aware that it is Cherrapunji. It's also called Sohra by the local name. That's where we get the highest rainfall. But what is interesting to notice, even in Cherrapunji, the place in the world which receives the highest rainfall, 3 months in a year, what happens when you don't harvest the waters when it rains, when it pours, you have shortage. So 3 dry months of a year, you have water shortage there. So the stark lesson that we need to learn from this is what? That wherever you are, the place of a low rainfall or of the highest rainfall in the world, if you do not know how to harvest the waters when it rains, you're going to have water shortage. So this land had this knowledge millennia ago to harvest its rainfalls. As we already said, Amazon basin has the highest rainfall in the world. Second only to that is the landmass of Bharata Varsha, as we called it. So we had floods and droughts, but also we had the skill to harness these rain, harvest these, and distribute it based on local topography. That's the beauty of what we had. We use the local topography very, very well. We'll see that over the next few minutes. See, if you see Ladakh, the northern state of Bharat, we have something called zinc, from the melting ice, they collected it in tanks and had waters for their use. Jammu, you had a kul. In Himachal, another variety of kul where they diverted waters for irrigation through check dams. Then you come to Himachal, you have Himachal, where they're getting waters. See how they're getting it. Then in Himachal, you one more, they culled out of stone shallow wells and stored the water, fresh water for use through the ocean. It's called Khatris. Then Uttaranchal, we have the Naulas, the small ponds. Then you come to Delhi, you have the famous diggis. There are many diggis all over Delhi. Then you have the Baulis. You have about 700, 800 Baulis in and around Delhi itself. Of course, many of them have gone dry, but you have this many. Tughlaqabad itself has some 300 plus Baulis. Then you come to North Rajasthan, Alwar, you have Johad, earthen dams. Look at Rajasthan is supposed to be a dry area, desert area, but look at the number of water harnessing systems we had. Nada Band in Mewar, Kuiberi in the Thar Desert, then Bears, again the community wells. Then you have the Jalras, the tanks in the Thar Desert, then Nadi, again the ponds in the Thar Desert. See how many systems. Khadin, look at how the Khadin. We'll just show you a small animation of this. When you see, it's desert. So the soil is very gravel. They allowed the water with small bunds to collect there and seep in. And when they collect and seep in, what happens? The gravel sand allows the water to become filtered. Then they draw the water downstream. So that is how they manage their water so well through the millennia. Then again, if you see Kund, Tankas, very famous, and they're all heirlooms, heritages for families, lineage for generations to come. And all the forts, the famous forts in Maharashtra, Rajasthan, Madhya Pradesh, everywhere you have forts. Look at the within forts, how many varieties of water harnessing systems did they have? Amazing, isn't it? So, the siege of the fort for 3 months, 6 months, they had no problem water. Then you come to Rajasthan, you have the percolation tanks called Rapats. In the western Rajasthan, you have the Chandelas, other parts. Then you have the Bandelas. Again, tanks. Look at that. And Rana of Kutch, a dry area, Vrida, shallow wells where they could collect the waters, valves, the great valves of different parts of Bharat. One of the greatest valves, Abhineri, which is a poetry in stone. Also, I can say built about 1,100 years ago. So they had vertical shafts and horizontal shafts. And in Madhya Pradesh parts, you go to Arunachal Pradesh, you have Apatani, Nagaland, Zabos, Chiozi in again Nagaland, and you have Meghalaya. We think drip irrigation is something new that we are given to the world. I mean, the world has given to different parts, including Bharat. But look at this. We use bamboo pipes for drip irrigation in those days and created so that we took water to where needed. So wonderful. Using bamboo pipes, we've done it. The hollow shaft in them. Then go on, you got Assam, you got the dongs, famous dongs of Assam, Bengal Jampois, Jharkhand Ahar pines. Then you have the talabs of the Bundelkhand region, very famous talabs. Many people are pointed about, and Odisha, where Sri University is. You have the different katta mundas, which are all the earthen check dams. It's a check dams, a series of them. From there, going on to the west, Daman, you have the Fards, different areas. Then Maharashtra, Koli, of course, Koli is a very popular name. You know how it all's there. So the Bandaras of Maharashtra, again, then you come to the Ramtek model, which are connected underground water. Then the Keres of Karnataka, for example, where different parts of Karnataka, many Keres, a series of tanks. Then you come to Andhra Pradesh, you have the Cheru, famous Cherus of southern Andhra Pradesh, especially, the store water. Then you come to North Kerala, you have the Surangams, the horizontal and vertical wells. Surangams, look at this. This is a picture of a very old Surangam we have here for you to watch. Then the Korambu, because they are slopes, so they are mud walls connected so that to save water. And the other places, Palakkad, where you have a lot of water. About the Varahamira is also written. Then in Tamil Nadu south, you got something called Yeri, the tank system of the land, of the southern land. So, Urani, which is the public water bodies. So, Urani, even the islands of Andaman Nicobar, they have jack wells. Look at this. So, it's a system of having and what you call the Anaikat. This is in the southern part of closer to Kanyakumari, or something called Anaikat. So, what we've done is actually, if you see in north Ladakh, when we saw 5 minutes back, we have something called Zing. And in Kanyakumari, you have something called Anaikat. So it's a Z to A of water harnessing. Because whenever we speak about something, we speak about A to Z. Here we see something, we speak about something opposite. Z to A of water harnessing is in, but not just A to Z is there. Z to A is also, that's a beauty we have had in this land. So we had a series of systems where we knew how to bring good. That's a larger point. Where we create a habitation. Around the habitation, we had the skill, the technology, the capacity, the propensity to bring water to where our habitation is. That's the beauty of what we did repeatedly.
And why did we do all this? I mean, what is so unique about India that people were not only settling by the rivers, but they were also doing this particular water harnessing, and that has also contributed to the character of this land. So, what is so unique about this India, if you look at it, that's such a beautiful aspect that comes to light.
We have written this in our book, U-Turn India. Look at this. In a year, we have 365 days. Obviously, all of us know it. Similarly, if you look at this, we have how many hours in a day? 24 hours. In a month, how much do we have? We calculate like that. In a year, we'll come down to 8,760 hours in a year. Of this, we have only 100 hours of rainfall actually happening in this land.
So even though it actually rains for 4 months, if you really count the exact time when you have water pouring down from the sky, that would actually total up to about, on an average across the land, for about 100 hours. So what does that mean? It means that out of 8,760 hours, if only 100 hours it's actually raining, for 8,660 hours there is no rain. And so if it really boils down to close to just 1% of the whole year, it's raining, whereas for 99%, it is dry. And if you're not going to collect the water when it is raining, then your buckets are also going to stay empty. So this was something that the people across this land had realized, had experienced, and which is why they had their water harnessing systems everywhere to ensure that they could collect this and put it to use through the year. And if you look at it, that is the reason why this land had 3 harvests a year. But it also brings out a beautiful aspect of the people of this land, that this gave them a mentality of saving as well. Because we were saving every drop of water, we started saving everything. So this is kind of a byproduct of how environment has shaped the people of the civilizations.
So we look at this. What we need to understand is all this is happening. There's an ecosystem for water. So waterscape is there in the world. So from the oceans.
So you have water from the ocean getting evaporated, going up as clouds and water vapor. It gets transported, moves across, and then in another land, it precipitates as rain. Sometimes you have snow on glaciers, you have permafrost, and so on. But this water which falls on land area eventually ends up as surface water, or it percolates inside as groundwater. But both of these eventually come back to us in the form of rivers and lakes. So you have springs from which they all join, water starts spouting, and slowly they all come and join. So unless you are not doing all this borewell business, you really had only rivers and lakes and these kind of water harnessing bodies that you built, and the water again would come back, they would discharge into the ocean. From the ocean again, it would go up into the sky. So this is the entire cycle, and we had a nice name for this, from Gagan. So from Gagan, it comes down and goes back to Gagan. So this was our Ganga. It is a Ganga cycle. And the challenge now, therefore, for us, we know all this water is not usable. So what is it? It is this fresh water which is on land that we can use. So increasing this fresh water. So when we say water governance, how do you increase the amount of this fresh water and make it more available for people? And the amount of this fresh water is actually very, very little, because actually 98% of world water on this earth is salt water. Only 2% is fresh water, the water that is on the land. And even amongst this 2%, 87% is in the form of ice, and only about 12 and percent is underground. It is not accessible straight away as groundwater, and 1% is flowing on the surface as rivers and lakes. And when you look at this, so therefore, when you say fresh water that can be used by people where they are without going to the glaciers, then we're talking about just the small 13% of water. And we're looking at how to save, how to maximize this 13%. Now, there is something that we fail to see. When we say groundwater, we think of it somewhere under the ground alone, and below us at ground level. What we fail to see is whenever we look at a hill and we see water falling, when there is rain, beautiful waterfalls, this water is coming because of rains, as well as a lot of springs here. Springs join and everything.
Natural ground springs.
They come and then they flow down. But this hill itself, as it is raining, it is made up of soil and rocks and everything. And this hill itself is a veritable store of groundwater. So there is groundwater in this. So when you look at a hill, look beyond the green, you will see a blue inside. So they are also water stores. And from each of this is where the springs are coming, and slowly small springs, and they join and they form the beautiful circulatory system for this land. So this is Bharat with all its rivers and river basins. And these natural springs, if you look at it, it's a beautiful cycle and an ecosystem as well. Because whenever there are natural springs, that means there is groundwater, because only where there's groundwater, it's going to come out as a spring. Now, if there is groundwater there, then it's going to support plants and trees around. So the forest cover is going to exist. Where there is a forest cover, naturally wildlife is going to exist. Now, where there is wildlife existing, these forests are going to stay guarded, because people are not going to go and destroy these very easily. So these natural springs, and it's again, the forest and these water springs, and these forests are needed, because where there is forest, it will cause precipitation, it will cause more rains as well. And there is more rain, more gets into the groundwater. More gets into the groundwater, more natural springs. More natural springs, again, more forest cover. So this is a beautiful ecosystem that supports each. So therefore, we see that this kind of a connect between the green and blue is very important. And when we plan for water governance, it is this green and blue connect that we have to ensure. And we have to look at various aspects of this green and blue connect. At every point, we have seen how small sources contribute to this. So at every of those small sources, you have to go and look into how to ensure that that source of groundwater can be preserved, protected, and used carefully, judiciously. So both the usage has to be governed, the preservation has to be governed, in order to ensure that you have sufficient amount of fresh groundwater.
Thank you so much for giving us opportunity to make this presentation. Namaste.
Namaste.